You are standing at the edge of a cold Siberian cave. Snow dusts the rocks, the air bites your face, and somewhere inside that darkness, a tiny piece of finger bone is about to change the story of what it means to be human. Because for most of human history, Earth did not belong to one kind of human. It belonged to many. Your species, Homo sapiens, was only one branch on a crowded family tree. Homo sapiens simply means wise human, the name scientists use for modern humans like you. But 50,000 years ago, that name did not describe the whole human world. There were Neanderthals in Western Eurasia. There were Denisovans somewhere across Asia. There were small-bodied humans on the island of Flores in Indonesia, later nicknamed hobbits. And there may have been others whose bones have not yet been found. So what would happen if you met them? Not monsters, not apes, not fantasy creatures. Other humans? Imagine walking through a forest at dusk. Your feet press into wet soil. A bird screams above you. Smoke rises from a camp that is not yours. Then you see them. They are not quite like you, but they are not completely unlike you either. They make tools, they understand fire, they survive cold, hunger, darkness animals and each other. Their faces carry fear and memory. Their hands know stone, bone, wood, and skin. Would you recognize them as people? Or would your brain freeze because the modern world has taught you that there is only one human species? That is the strange part. Today, being human feels simple. You look around and see only Homo sapiens, different languages, different faces, different cultures, but one species. In the deep past, the planet looked more like a living museum of human experiments. Some were powerful and broad. Some were small and island-shaped. Some are known from skulls and skeletons. And one of the strangest was first known from almost nothing at all, a child's finger bone. In 2008, archaeologists working in Denisova Cave in the Altai Mountains of Siberia found a tiny fragment of bone. It was easy to overlook. Small, plain, not dramatic, not a skull with staring eye sockets, not a spear point, not a painted wall, just bone. But scientists at the Max Planck Institute for Evolutionary Anthropology, including Svante Pääbo, did something revolutionary with it. They studied ancient DNA. DNA is the instruction code inside living cells, and ancient DNA is that code recovered from long-dead bodies. Most fossils are silent. This one still whispered. When David Reich and other researchers published the Denisovan genome in Nature in 2010, the result was shocking. The bone was not from a modern human. It was not from a Neanderthal. It belonged to a previously unknown group of ancient humans. They were named Denisovans after the cave. Think about that. An entire kind of human entered modern knowledge through a finger. No complete skeleton, no clear face, no village, almost no body. Just a genetic ghost. What did a Denisovan look like? For years, that was one of the great frustrations. Scientists could compare their DNA to yours, but they could not easily draw their faces. A few teeth and bone fragments suggested they may have had large, robust jaws and unusual molars. Robust means strongly built, not delicate. Then another clue appeared far from Siberia. In Baisha Karst Cave on the Tibetan Plateau, a human jawbone known as the Shiahi mandible was identified as Denisovan-related through ancient protein analysis. Proteins are molecules that build body tissues, and they can sometimes survive where DNA does not. This jaw was at least 160,000 years old. Now, the Denisovans were not just a Siberian cave mystery. They had reached high, cold landscapes where the air was thin and the body struggles for oxygen. And here the story gets even stranger. Some people living today carry Denisovan DNA. This is because ancient groups met and had children. Scientists call that introgression, which simply means genes from one group entering another through interbreeding. A 2014 Nature study led by Emilia Huerta Sanchez showed that a version of the EPAS1 gene in Tibetans appears to have come from Denisovan-like ancestry. EPAS1 helps the body respond to low oxygen at high altitude. In plain English, a vanished human group may have helped some modern humans breathe better in the mountains. So Denisovans did not fully disappear. Part of them is still inside living bodies. Your world is haunted by inheritance. But now leave Siberia, leave the snow. Travel south across forests, rivers, islands, and ocean wind to a warm cave on Flores Island in Indonesia. The cave is called Liang Bua. Inside it, in 2003, archaeologists uncovered bones that looked impossible. The skeleton was small, very small, about 1 meter tall. The skull was tiny. The brain was much smaller than yours, yet the bones were not from a child. They belonged to an adult. Researchers Peter Brown, Mike Morwood, and their team described this species in 2004. They named it Homo floresiensis. The world gave it a nickname, the Hobbit. The name sounds cute. The reality is deeper. Homo floresiensis was not a fairy tale creature. It was a real human species living on a real island with real dangers. Its bones at Liang Bua date roughly between 100,000 and 60,000 years ago, and stone tools linked to the cave layers extend roughly from 190,000 to 50,000 years ago. That means this small human may have lived surprisingly late. Late enough that your own species was spreading through the region. Imagine meeting one. You are taller, your stride is longer, your brain is larger. But that does not mean you are automatically better at surviving there. Flores was not your world, it was theirs. The island had giant storks, Komodo dragons, steep forest, volcanic ground, and small elephant relatives called stegodonts. Stegodonts were extinct elephant-like animals with long tusks. On islands, large animals can shrink and small animals can grow large. This is called island dwarfism and island gigantism. Island dwarfism means a species becomes smaller over many generations because food is limited, predators are different, and survival rewards a smaller body. Flores was an evolutionary pressure cooker. A body did not need to match the mainland. It needed to match the island. This may explain why Homo floresiensis became so small, but for years, scientists argued fiercely about what they were seeing. Was this truly a separate human species, or was it a modern human with a medical condition? That question mattered. Because if Homo floresiensis was only a sick modern human, then the family tree stayed simpler. But if it was a true species, then the late human world was much stranger. More fossils changed the argument. At Menge, another site on Flores, researchers found much older hominin remains about 700,000 years old. Hominin means humans and their close extinct relatives after the split from the chimpanzee line. In 2024, a team including Yusuke Kaifu and Gert van den Berg reported an extremely small adult arm bone and teeth from Menge. The implication was startling. Tiny humans may have been tiny on Flores for a very long time. Maybe the Hobbit was not a recent accident. Maybe it was the endpoint of hundreds of thousands of years of island evolution. So picture the human world before the disappearances. In one direction, Denisovans carry fire through cold Asian landscapes. You do not know their songs, you do not know their family rules, but their genes say they met the ancestors of living people. In another direction, Homo floresiensis moves through tropical forest with small tools and sharp attention, short bodies, tough lives, a world of dragons, birds, caves, and volcanic stone. Elsewhere, Neanderthals survive Ice Age Europe and Western Asia. Strong hands, heavy brows, skilled hunters, deep knowledge of cold. And then there is your species, restless, social, inventive, dangerous. You are not walking into an empty planet. You are walking into a world already inhabited by other forms of humanity. What would the meeting feel like? Maybe it begins with footprints, not words. A broken branch, a stone flake, ash from an old fire, bones cracked for marrow. Marrow is the fatty tissue inside bones, rich in calories and precious to hungry bodies. You crouch. You touch the ground. Someone else has been here. Your heart speeds up. Because another human group can mean opportunity, trade, mates, warnings, shared knowledge. It can also mean violence, competition, disease, fear. The ancient world was not a peaceful museum. It was a living place where small groups protected food, children, tools, and territory. But the most counterintuitive twist is this. Extinction did not always mean total disappearance. With Denisovans and Neanderthals, at least some vanishings were also mergers. Their bodies disappeared as distinct populations, but parts of their DNA entered Homo sapiens. their genetic traces still shape immune systems, altitude adaptation, and other traits. The boundary between us and them was not a wall. It was a shoreline, sometimes separate, sometimes mixed, sometimes erased by time. Homo floresiensis is different. No confirmed DNA has been recovered from the hobbit fossils. Warm tropical environments are harsh on ancient DNA because heat and moisture break it down, so scientists cannot yet say whether your species interbred with them. Maybe they vanished without genetic descendants. Maybe their traces are simply too faint to see. Maybe the evidence is still waiting in a cave floor under dust ash and limestone. That is what makes them so mysterious. Denisovans are known mostly through molecules. Hobbits are known mostly through bones. One is a ghost with genes. The other is a body without a genome. Together they show how incomplete the human story still is. Your brain wants a clean ladder. Ape to caveman. Caveman to you. But evolution is not a ladder. Evolution is a branching bush where different groups adapt to different places, split apart, meet again, and sometimes vanish. A Denisovan was not trying to become you. A hobbit human was not a failed version of you. A Neanderthal was not a rough draft of you. Each was the result of a long survival experiment. Cold mountain air, island hunger, ice age steppe, rainforest darkness, volcanic stone. Every environment asked a question. Every human species was one answer. And now only one answer remains visible. You. That can make Homo sapiens look inevitable. As if your species was always destined to stand alone, build cities, invent screens, and look back at the others as curiosities. But the fossil record does not say inevitable. It says lucky. It says complicated. It says your ancestors survived a world filled with cousins. Some they may have feared. Some they may have loved. Some they may have absorbed. Some they may have helped destroy. The modern mirror is uncomfortable. Today you live in a world where human difference is usually cultural, political, or personal. People argue over language borders, beliefs, skin, money, and memory. But biologically, the differences among living humans are shallow compared with the gaps that once existed between human species. The ancient world reminds you how narrow the present is. The range of human possibility used to be wider. There were humans with different bodies, different faces, different brains, different adaptations, and different ways of belonging to the earth. Then the branches fell away. One by one, maybe from climate change, maybe from small populations, maybe from competition, maybe from contact with Homo sapiens, probably from many pressures at once. Extinction rarely needs one villain. A small population can survive for thousands of years, then disappear when bad weather, fewer births, less food, new disease, and a new rival arrive too close together. So if you met the other humans, the first feeling might not be triumph. It might be grief, because you would be looking at a path your family tree almost took. A different way to be human. A way that ended. And yet the story is not only sad. The Denisovan fingerbone proves that even a fragment can speak after tens of thousands of years. The Liangbua skeleton proves that a small body can force a giant question. The Menge fossils prove that one island can preserve an evolutionary experiment for hundreds of millennia. Your species is not the whole story. Your species is the surviving chapter. So the next time you look at your hand, remember the fingerbone in Denisova Cave. The next time you breathe easily, remember the high plateau and the ancient genes that may still help living people face thin air. The next time you feel small in a huge world, remember the hobbit humans of Flores walking under island trees with dragons nearby and stone tools in their hands. Humanity was once a crowd. Now it is an echo, and somewhere inside a cold Siberian cave, a tiny piece of fingerbone is still changing the story of what it means to be human.